All right, get out of here. Okay, comment 1, comment 2. So, even though I can't spell, and I'm going to make this bigger. All right, so if I'm just at this line, I don't highlight anything, and I hit Command Enter, it'll execute this over here. It doesn't actually execute commands, but you'll see when I hit Command Enter, it automatically goes to the next line. So it does, and if you keep hitting Enter, if there's more code, you say Command Enter, like x equals 5, y equals 4, and I hit Command Enter again and again. It just goes line by line, one by one. Okay. So we call them R files or R scripts, similar to do files. That's where the code is saved to your disk. If you do not have RStudio open and you double-click a file, that is an R file. It will open that R file and it will set the working directory to the directory of that R script. That is why the 2 files we downloaded had to be in the same place. If you have RStudio open and you double-click a file and it opens RStudio, it does not change the working directory. Right? It's whatever working directory you were in. Right? So if you already have something up and it says, oh, I was working on all this stuff and I double-clicked the new file and it brought it up, it doesn't change the directory at all. But if RStudio is not open, double-click it, opens in that directory. Okay, environment. Right? So this environment is empty off the bat. So it tells you it's objects or variables that are in R, that are Cs, that you've made, that you've created. So for example, you might write it, I've written a dataset, you might create a table or something like that and save that to an object. So it's just going to list them out and kind of give you a little bit of gist of their structure. Tells you what exists in memory and what is loaded, what did I read in. History, these are the previous commands you ran. It's pretty good to look at for kind of debugging, but again, don't rely on it as a script. You can highlight the things and then make it into a script, which I will show you in a second. Again, you can also type just the up key when you're in the console and look at the previous commands. So kind of like instead of function up in R, if I'm just on the console, I just go up, it'll just scroll through. I think I didn't run much. Z equals 4, R equals 2. All right, if I just go up, it'll just scroll through the previous commands. If I look at my history, right, you can hold Shift and highlight everything, and you can send that all to the console. And if I say send to source, and I go back to my file, it has taken all those commands, copied and pasted them into the script. So if you said, okay, I'm done kind of doing things interactively, I really liked what I did, I really liked the way the plot looked out, or turned out, I'm going to take all these commands, sorry, I'm scrolling through, I'm going to highlight them, send them to source, and it just copies and pastes them up here. I'm going to take all this stuff out. But again, if you're trying to say, what were like the last 5 or 6 commands, just you can go up or down and scroll through them. Okay, some other panes. So whatever working directory you're in, the files pane will show you the files on your computer in that directory. Viewer, it'll view data objects, so this will be really helpful for viewing, for example, data sets. Help shows when we look at the help files, that'll be where they pop up. Plots, all the pictures you make, all the plots you make, so you can scroll through them there. Packages, so I don't have that loaded on my panes, but if you are running something, so we'll cover this a little bit more in detail, but all we've done so far on your computers have been installing those packages. Unlike Stata ADO files, where if you've downloaded them and saved them to the ADO directory, you can use them anytime you want in Stata now. That is not the case for R. You have to load in that package if you want to use the functions from that package. That is because, like I said, there's over 10,000 packages. You don't want all that code accessible at the same time. And there's a lot of reasons for that. Because a lot of people, operations are not that unique and programmers aren't that clever. I mean, they're very clever, but they're not always that clever with respect to naming things, right? So, a lot of people have, a function called slice or something like that. So if you've loaded 2 packages that both have the name that both have a function called slice, you have to be more specific as to which one you want to use. So these are called kind of conflicts, and we'll get into how to deal with those. But, for example, let's say you have now like 10 packages that have the function slice in them. Right? You don't want to load all of them up. Also, sometimes loading a package takes some time. So let's say you're not doing any plots, you're just doing data manipulation. You don't want to load up all the plotting packages that you have. So you install a package and then you load it up in memory. All right, some other shortcuts, Command Enter, we already talked about. Control or Command 1 takes you to the script page, Control 2 takes you to the console. There's a list of keyboard shortcuts here, but navigating our studio gets pretty easy after time. But again, it's not a drop-down menu like Stata, and there isn't really one for R that I really know of. All right, so that's pretty much just an overview of kind of what we're looking at. Now we're going to get into some of the basic R syntax. A lot of this will be relatively redundant comparatively to the try R and some of the other things you've done, but I still think it's worthwhile going over and having any questions. So was anything of those who did take who had the time to try the RStudio or DataCamp stuff, was it relatively straightforward, or is anything kind of off? I mean, it's a totally different language, right? But nothing was off the walls. Okay. Okay, so here are some of the frustrations. The different versions of software. Try to standardize that here. Everybody's got R3.1. Everybody's got the new version of RStudio. Shouldn't be as big of a problem. When you are working with some people that have, you know, R from 7 years ago, sometimes things have changed, right? Just like, you know, if you have someone with Stata 11 and Stata 14, you know, you might not have the new, I forget what, XDME Logit or whatever the new glands they put in there. I don't know. I haven't updated my Stata in a while, but I know they did stuff. So, data type problems, right? So just like in Stata, I will say the one thing that the Stata viewer really has that R doesn't off the bat, it visually shows strings as red, numbers as black, and labeled things as blue. I will say one of those things doesn't really make sense in R. You don't make factors such as categorical variables as like encoded as 1, 0, 1, 2, 3, 4 with labels on top of them. You just put the labels in there, and R knows how to handle factors such as that. But it does have some things when you plot, when you show a column of a data set that give you some intuition what class it is before having to actually go in and dig, like, what class is this thing? Also, working directory problems. If you've worked in Stata or other systems, you know what I mean, right? If you're using relative paths or using absolute paths, you have different problems in different areas, right? If you're using relative paths and somebody's folder structure is completely different, you're going to have a bad time. If you're using absolute paths like, C drive : John Michelli / whatever, and you try to give that to someone else, you're not going to have a great time, right? So we're going to be talking about relative paths and that kind of stuff. R is case sensitive. Little x and big X are totally different. Little x can be a data set. Large X could be a model. It could be a list of models. It could be a plot. And that being said, you can have 2 columns with the same name but different cases, right? So age and age can be in there, 1 capital, 1 lowercase. You can technically, we will not have the case here, or most of the data sets you have, you can technically have 2 columns of a data set with the exact same name. It's not great. I don't believe in the way we're going to read in data. That'll be allowable, but it's possible. And we're going to talk about tab completion. Okay. So again, the way you usually start a script, you open up RStudio, File, New, RScript, and we're going to save it in the directory we're choosing. I'm going to try something different with you guys because I think it'll work better with you, honestly, than previous years. So, okay, so there are a thing called projects. So I would say File, New Project would be the way to go. So we're going to do that. And what's going to come up are 3 different kind of options: a new directory, an existing directory, or a version control. Don't worry about the version control. We're going to do a new directory.
My R is still busy.
Your R is still busy. You're,
when I change the font, do like stuff?
Well, why don't we close it and then we'll show you how to install those packages one by one later. So it's not that big of a deal. So let's just close it out. You don't have to worry about saving anything. Yep. Don't save it. It's okay. Finish. It's fine. Okay. So file, new, new project. We're gonna say new directory. We're going to use an empty directory, but I do want to highlight something here. We're not going to touch on it, but there is an interesting component that has come out of R called Shiny, which will allow you to make kind of web apps to do interactivity and stuff like that between a website and R. Right now, we're just going to start with an empty project. I'm going to put this on my desktop. And I'm just going to call it R class, for example. I'm going to hit enter. So what should happen? It should close whatever you had up. So you can put it wherever you want, name it whatever you want. What it should do is close out whatever you had, but it's going to do two specific things that are kind of important. Just going to wait and make sure. So everybody have a project kind of set up? So, one, on your console, this is where your working directory is. So that should be set to whatever subdirectory you made. And this other thing, up here, it should say the name of the project. So now, if you have multiple projects, if you click, for example, down here, I make a lot of R packages and a lot of Shiny apps, for example. These are all different ones I work on, so I want to swap between them. I can just do that. I'm going to close this out real quick. The other thing you should note, I'm going to go into that R class folder. You're going to have this .rproj folder. So, although if you had RStudio up and you double-clicked an R file, it's not going to change the directory for you, right? If you double-click an R project folder, what it'll automatically do, open up an R. If you already had RStudio up, it'll open up another one. If not, it'll open up an RStudio in that working directory with that project loaded up. So that project loaded up, let's say, for example, let's make a few. I'm going to make a couple files. Okay, I just made two simple files. One just has a comment in it. We'll talk about comment operators. One just sets a variable x to be 4. I'm going to close it out. Load it back up. So those two files are still loaded in that project. So whatever you were working on, whatever script you were working on should still come up. The other thing that's really nice is this go-to-file function. So let's say you have like 20 scripts in there, right? You don't want to have to go through and figure out which one. You can type in here, and what this will do is two things. It'll look for files with whatever search string you have in there. And it'll also look for, inside your scripts, objects with that name. So let's say you had a really weird name like, this is my favorite variable. And I'll actually set that to be x. And I can say this. So if you, for some reason, really know what you named in something, or you're like, this is like best plot ever, or something like that, and you made an object or something like that, or you just had, you have some inkling, you're like, I forget where that is, it does some smart searching, right? So this is a good way to kind of do some project management. And again, now let's say you had a data set within that folder. Like you can say x equals, and we'll talk about this, read.csv, the file.csv, and you know that when you load this project up, the file will look in this specific directory, right? So it's good for when you, for example, have, let's say you have a data folder or something like that, right? You can specify the files that you want to read, the files that you want to save, using relative paths versus absolute paths, because you know how this, whenever you open this project, where it's going to be, where the other files are, and kind of the organization of the folder. So that kind of usually gets rid of a lot of I'll call them working directory woes. So this is not, I mean, this doesn't really work so well. I mean, especially if you have a shared drive and all that kind of stuff with shared stuff. But as long as that's kind of, everybody maps, this folder to the F drive, that's usually really shareable across people and stuff like that. So sometimes when we've done everything, you can kind of zip up this entire folder. Somebody can open that R project folder, and you know that when they open that project folder, they'll be set into that directory, and all things will run relative to that. Okay. So, commenting. R does not have a multi-line comment operator. / doesn't exist in R. Okay? Pound sign is what you got. You put it at the beginning of the line, you can comment. Okay? You put it anywhere in a line where it's not essentially in a string, it's a comment. So, for example, this is a comment, all this kind of stuff. You can put pounds still within a comment, right? So this doesn't, for example, end the comment. But you don't have something that says start a comment, here's a bunch of code, end the comment. I will say, though, you can, in our studio, there is, if I highlight everything, for example, and you go to code, comment, uncomment lines, usually Command-Shift-C or Control-Shift-C for comment, you comment the entire thing out. Sorry, let me make this a little bigger. So although it doesn't have a multi-line commenter, usually what I do is you just highlight what you want to comment, do Command-Shift-C, and you can toggle on and off between commented and uncommented code. Okay? Okay. So, again, if you've done some programming, this is just kind of like an example header to say, the title, the author, the purpose, what are we doing with this? Some other comments about the overall gist of what this script's supposed to do. All right, so now I want to pretty much describe really briefly the way these slides are going to be done. So everything you see in gray is code, right? And usually it'll have some syntax highlighting around it, and almost everything that has code will have the output directly below it. Okay, so these are just text. This is code. This is the output. Okay. Oh, disclaimer, all these things, all of these slides, every single one of them was written in R Markdown, in a language that, so all of this was written in R, more or less. It's, and you can see all the stuff that was used to create this on the website. Okay, so R is a calculator, right? So if you're in the console, you can do the basic stuff that you normally would. 2 + 2 should give you 4. Yeah.
The place where you type in things like I have to go off and it says this.
So console, the way you type in stuff here, but yeah, somehow the script went by. Yeah.
Oh.
Yeah. So sometimes things can be pulled up on your console. So what happened, for example, things were pulled up. Let's see if I make this all the way up here. You kind of can't see the other things. I don't know if the Mac version does that, but you usually just have to click one of these and you should be able to see all 4 panes. I believe there has to be all 4 panes in that thing. Okay. So if you type in, the R console, just like you would with anything else, just a calculator, 2 + 2, 2 × 4 should give you 8. 2 × 3. So the caret or the star is the power operator in R. So 2 to the 3rd, we get 8. And you'll note whenever you write in a command, R thinks by default you want to print the thing out. So you don't have to. You can run a command, not save it to anything. That's fine. So you can use all the standard operators, caret, star. It works with all the standard order of operations. So the way I was taught was please excuse my dear Aunt Sally. So for parentheses, exponents, multiplication, division, yeah, addition, subtraction. So standard order of operations. So if you want to group things together, you got to put parentheses around it. So let's say 2 times 3, make 6, square it, make 36, add 2 to get 38. Similarly, 1 plus 3, make 4, divide by 2 to get 2, and then add 45, right? So this isn't so, special, for example, with respect to numbers, but if you're doing this with variables, it is really important. Some operations you don't really need to be so worried about parentheses, but definitely when you're calculating some summary scores, especially in public health, there's like some weird subtractions and additions and that kind of stuff. And if you want to do it in all one command, you have to just be careful about that. So again, for this crowd, I mean, we can do this, but I think kind of everything kind of going on at the console, so we're going to go through this a little bit quicker. All right, so now, how do you assign things? You can create variables within the R environment from files on your computer. But you can also just assign it to anything. So R uses 2 assignment operators. One is the equal sign. X equals 2. That is what I use. That is what 99% of the slides probably will use. It also has what's called the arrow or the assignment operator. So it is the less than sign and a hyphen. This was used for the last 20 years or something like that. Equals became like a thing to actually be able to do in the last 5 or maybe like 7. So, but we want you. I recommend equals. It's only 1 keystroke. It makes sense to a lot of people. It's standardized over like every other language known to man. But the assignment operator will be out there. We'll be in millions of Stack Overflow posts. So variable names are case sensitive. So X and little x are different. Also, some people really believe this is the way to do it because it makes sense. It is a one-way operator. You assign 2 into X, right? It's not two-sided. You cannot say 2 equals X. That does not work, right? It's the left hand is important. So okay, and I think in code school, the code school try-R, I think they might have shown both ways as well. So X equals 2. Now, if you run this command, X equals 2, you will see something pop up in your environment, and it'll say X in there. And so if we just type X, it'll print out 2. And if we take X plus 4, it'll be just the same thing. Or X times 4, sorry, it'll be the exact same thing as 2 times 4. We'll get 8. X plus 2, get 4. Right? So the equal sign is how you assign things. And again, sometimes you want to assign it to just a number, a whole set of numbers, a column, a data set, and so on. So I would say the big thing for people coming from Stata, for example, is this concept right here. Not everything is relevant to a data set. Okay? That is the biggest, I think, jump. Because Stata, you say sort X. You know X is a data set loaded in memory. That is not how R works. R can have hundreds of data sets loaded in. 50 models fit in a variable. 50 models in 50 different variables. It doesn't work in the same way. That makes it more flexible, but also sometimes more confusing. So when I say X equals 2, that is not a column in a data set. That has nothing to do with a data set at all. It's just a number 2 assigned to a variable named X. So whenever I want to use 2, I can use X and it'll be the exact same thing. Yes?
What I wrote in the console is supposed to show up in the script as well, right?
No.
Oh, you showed something earlier.
So I said if you put things in the script, you can highlight it and then hit Command Enter to send it to the console.
Oh,
yes.
Not the other way around.
Not the other way around, correct.
Oh. Okay.
Yes. So we will get to what's called a data frame. A data frame is the thing that I would say most people consider a data set. It's got rows, it's got columns, it's got column names. So this is the majority of Excel spreadsheet data that we use. Pretty much every stated data set that you kind of ever work with has rows and columns, right? Names for the columns. They're a little bit advanced and they have quirks to them, so we're going to start from the ground up a bit. So we're going to introduce kind of what these called one-dimensional classes. So just a string of numbers or a string of characters. A set. String is the wrong word. A set of numbers or a set of strings or a set of trues and falses, right? So they're called vectors. So vectors can have multiple observations or just one observation. It can be 1 or 100. But each observation has to be the same class. So kind of like a column in a data set, a column in a data set you can consider to be a vector. They all have to be the same type. If one of them is a string, they're all strings. If they all are numbers, you can't change one of them to be something else and expect them all to say numbers, right? So one of the functions that we're going to introduce, so this is the way functions work. Functions, it's function name, parentheses, and argument you pass in. So we just define x to be 2. We say class of x, and it says numeric. So to R, x is a numeric vector. That's the terminology that's used in R. So y, we're going to say y is equal to hello world. So let's note string, and we say print y, and then we say class of y. So let's look at these 3 things in conjunction. 1, class of y is a character, right? So numbers by default, we're given this class numeric. Characters or strings are called characters, and when we print them out, we should see 2 very different things. So when we printed x before, I'm just going to jump to the last slide really briefly. We see this bracket 1, which is nothing to do with the data set. It's when you print, for example, 1,000 records or something like that, which I don't recommend you do. It'll fill over and over again. And if you want to see, for example, oh, that's a really weird point. This is just an indicator to say, what index is this one on this row? So, for example, let me show you. If I'm going to print 100 random normal numbers. I'm going to have to make this a little bit smaller. And you see all these numbers here on the left-hand side. So this is just pretty much saying, this is the 71st element of this vector. That's just the index. So just to give you kind of a guidepost to say where you're at in this whole thing. To say, like, what record is that? I mean, we'll do it programmatically to say, like, which one, is missing or which one is over 100 or something like that. We can do that. But if you're kind of just getting a gist for the data and say, I'm trying to look at kind of these rows, that's all that bracket number means. Just give you an index. So when it prints out, when you print x equals 2, you'll see it's just the number 2. No quotes around it, nothing. When you print hello world, it's got quotes around it. So these are just some guideposts, just some markers that say, hey, this is a character. Okay? We will get into another format a little bit later called factors that are the way you really encode data into categorical variables. When you print those are printed a different way as well. So the way, when you just print something, you can get a general handle as to what type of data you're printing. Whether it's treated as a string, treated as a categorical variable, or it's treated, for example, as a number. Right? This is never going to be printed without, this is never going to be obviously confused to be a number. But there are some times, for example, when you're reading a data set, one of the columns has all numbers, but somebody put in the word missing in there instead of coding it, for example, as like 999. When you read it into R, that column is no longer numeric, right? So if you printed like the first 5 records, it would be quote the number 2, quote the number 4, and so you know, oh, that column, before you're even doing class on it, you know that column was read in as a character. Okay? You can use single or double quotes in your strings, or to encapsulate your strings. It doesn't really matter. Kind of, I would say, choose one and go with it. I do not recommend kind of, it's just, I wouldn't say strange syntax, but it's just inconsistent syntax to be like, y equals double quote, hello world, z equals single quote, some other string. So either pick double or single, whatever kind of makes the most sense to you. Kind of go with that. All right, so let's try assigning your full name to an R variable called name. and just use double quotes. That's just. So again, name equals John Michelle. If I just write name out, it'll just print it out. Again, you gotta put quotes around it. If you did, you get some error. If you put single quotes, you'll be totally fine. Right? But again, just length 1. There's just one thing in this element. Name just has one thing in it, just my name. We're gonna use that in a minute. So okay, I wanna make a bunch of things. I don't wanna just have a vector of one thing. I wanna have a vector of like a bunch of things. So the way you do that is the C function. C stands for combined or collect. So it allows you to join single objects into a vector. It's usually creating a vector of numbers, character strings, or other data types. So if I say I want to create a vector of length 4 and with the numbers 1, 4, 6, and 8 in it, this is the way you do it. So again, I think this is probably the 1%. We just wanted to again reiterate that you can use the assignment operator. I would still use the equal sign. So you can say x equals 1, 4, 6, 8. And you can print it out. And you say class of x is numeric. Sorry, I do want to say, I forgot to tell you this. On the website, all the code that I'm looking at up here is, so let's just go to the website really briefly. All the code that I'm showing you is in this R file. So for every single lecture, there's an R file. If you download that, that'll have, for example, if I click this, name equals, x is 1468, right? All the code that you see on the screen, there's an R file associated with it. So if you want to download that and open that and kind of command enter and run along, that's totally fine. That might be more intuitive. Okay. So again, it'll still say it's a numeric. So R doesn't care if it's got 1 element in there, 4 elements in there, 100 elements in there. As long as it's the same, they're all numbers, pretty much it calls it a numeric vector. All right, so let's try assigning first and last name as 2 separate character strings into a single vector called name2. So let's do name2. It should have 2 elements that are collected together with this C function. And the first element would be your first name, second element would be your second name, be your, last name. I know, really exciting. Now we have the vector length 2, right? No, so again, as long as they're the same type, everything stays the same. John Michelle, 2 separate words. This is the way I will describe it, and this is like the terminology we use. I don't know. It just sounds natural to me coming out of my mouth, but to others, this is a vector of length 2. That's what we say. I don't know why, but I don't know if that sounds intuitive to others, but that's the way I'll describe them. A vector of length something. So, for example, x before was a vector of length 1, a numeric vector of length 1. So again, you can do the same thing collecting numerics, collecting characters, but when you mix and match, some stuff goes a little bit differently. Did you have a question?
Yeah. So once you create an object, can you, rename it, change it, delete it, like all?
Yes. So before, when I was playing around, right, I said, let's say x is this, right? X is this is just, I made 100 random normal numbers, and I assigned it to x. So if I go to my little environment thing over here, see x, it says num, 1 to 100, and it shows the first couple values. So it says a numeric, it's of length 100, and it's got these first 5 values in. X is 4. those 100 values are gone. What happened before? No memory of it, completely trashed, right? So, for example, when you reassign a column in a data set, we will show, you say like data set way to grab column equals new values. And so it's replacement, it's reassignment. So, yeah, so there is no gen in replace. It's always replace. Let's put it that way. So if you had something in memory, right? Let's say you had a data set in memory that you called like D, like you worked on it for like 5 hours. There are ways to kind of get it back. But if you reassign D, that stuff goes away. So, that being said, the practices we hope to teach in this course are that you had code to do all the stuff that you were doing, and you didn't, save often and save large incremental steps. So you'd be able to get back to that point. But if you assign it to be D, it says, all right, out with the old, in with the new. Okay? So this is good and bad. I think it's good because a lot of times when you're doing things with intermediate steps, you can tell. So kind of like authors, when they do the word distributions, they can kind of determine if an old book was from this person or that person. For example, you can determine kind of who wrote a function, who wrote a script by their intermediary things. Like I use X, I use Y, I use temp a lot. Elizabeth Colantoni, who's in our department, I've seen a lot of her code. She uses junk. Junk is one of her kind of temporary things that aren't relevant, that are like, I need an intermediate step, and I'm going to trash this thing later. Or it's like, I'm going to replace this thing. So, for example, up in this code, I might have created a temporary variable, done some manipulation to get some summary measure, added it to a data set or something like that. And then later in the code, like I'm going to do something similar or something completely different, but I need just a thing to hold it, do some manipulation, then toss it. I might use X for both of them. So it's good, but something that you want to make sure you don't overwrite. You usually make, obviously, you make a lot better variable names than that. X and Y are not intuitive. I will say if I'm using a script where it's only one data set, I will use DF for data frame a lot, or DAT or data. Those are not the greatest names. But if I have multiple things in there, they will be named totally different things, like demog, follow-up, base, that kind of stuff, and baseline follow-up, demographics. So, we showed you class, we showed you C, now there's length, right? So length is specifically more or less for vectors. So you say length of X, it's 4. So it's the 1, 4, 6, 8 that we just assigned it to. So you want to say how long a vector is. So it gets the length. And for example, if we say Y, we can print it out again. If we say length of Y, it just says 1. There's only one string in there. That is not the number of characters. There's a function called nchar, N-C-H-A-R, that if you wanted to get the number of characters in this string, that is how you do it. But when we're talking about vectors, when you say length, I'm saying how many elements does it contain. So when you say length of this, it doesn't count 5, 10, 11, 12 letters. It doesn't do that. It says there's only one character in there. Yes?
Quick question. This may be a good thing, but let's say for the variable X, which has 1, 4, 6, 8.
Yes.
You won't be able to see that in a data window somewhere in R.
In your environment, you should be able to see that.
So it says, right, yeah, I see that.
Mm-hmm.
But not like a spreadsheet where it says X on the top and then 1, 4, 6, 8.
So,
rows.
You might be able to do that. Yes, but you can. Generally, this view function is for rectangular data. So when we talk about a data set, we'll be able to use that.
Okay.
But we will show. I generally use head. So there's head and tail. Head will show by default the first 6 elements of something. If that's a data set, it'll show the first 6 rows. If that is a vector, it'll show the first 6 elements if there are 6, for example. So that's what I use. So this view, so that's another reason why we use RStudio. View is in RStudio. It's not in R. So it's a specific thing to using RStudio. But it does show you kind of, I'll show you when we read a data set, and it'll automatically bring up a viewer, and it'll show you kind of the gist of the data. And I'll talk about, I believe it shows like the classes of each thing, which ones are character, which ones are coded as that. It's not color-coded, but, you know.
Right.
It has to be a capital V. Right?
Capital V, yes. Sorry, yeah. Yeah, sorry about that. Fonts. Fonts are important. Yeah. So this is a capital V. Yeah. I think that was the one. Yeah, that was one of them. That was really not easy to see. Okay. All right. So what's the length of the name variable? The one that we said before. With 1. Name 2? 2. Put your first and your last. Right? So again, length of name 1 is 1. Length of name is 2. So that's one way you can count things. We're going to talk about ways to kind of count rows in the data set using some different functions. But if you just grab a column, you say length of that, it'll tell you how many elements there are in it. Right? So that's one way to count the number of rows. Not always the best way, especially when there's missing data and stuff in there. We have totally different ways to count that stuff up. Again, so this is important. So although we showed like 2 plus 2 is 4, great. X plus 2, it does vectorized operations, right? So what it'll do is element-wise, the 1, the 4, the 6, and the 8, add 2 to every single element. So that's why you get 3, 6, 8, and 10, right? If we multiply by 3, again, it does everything element-wise, right? So it multiplies 3 by everything. You can also add 2 vectors of the same length. So you add 1, 4, 6, 8 to 1, 2, 3, 4. Okay? And then it says the 1 and the 1 add to 2, the 4 and the 2 add to 6, the 6 and the 3 add to 9, the 4 and the 8 add to 12. Okay? So this is really relevant when you have 2 columns, right? You say column A plus column B of this data set, and I'll add them element-wise. It doesn't do anything, you know, matrix-wise or anything like that, anything crazy on that. And you can still add something of just length 1. Now, what happens when you do name 2 plus 4? Name 2 is your 2 names. So it comes out, I forgot to change something. Says something that is, welcome to the world of errors. Error in name 2, let's say plus 4, non-numeric argument to binary operator. So that's saying you didn't put a number in there. You might get this error. For example, you read in a data set, didn't do kind of some due diligence, making sure all the classes, everything read in fine, and you started to try to do some manipulations, or you had a report that totally worked fine. Somebody put some little wrench in the data, and now things are starting to break. That's because name 2 is a character, and R says, I have no idea how you're trying to add your name to the number 4. Okay? It doesn't make sense to me, so it gives you an error. So, again, like you were asking before, now we're going to assign y to be something different. Before it was, hello world. Now y is 2, 6, 9, and 12. It's no longer hello world. It's effectively overwritten by assigning data to a new variable. Okay? Don't say replace, none of that kind of stuff. And again, y and x are not bound in any way. If you change x, y doesn't change. Okay? So although y was defined on that value of x at that given time, you change x to be something completely different, y stays the same. They are not linked in any way. When we talk about data sets, things, if you reorder rows, for example, they'll reorder together. Right? It's not going to, doesn't break things. You can break things, but I usually don't want to. But for example, if you change x to be your name, y still is going to be 2, 6, 9, and 12. Okay? So, let me go back to this. This is really important. This was one of the first things when I got into R, I was really confused about. Because one of, I think, the first assignments we ever had was sort x. So there's a sort function in there. And what it'll do is it'll sort the numbers. And coming from other languages like C++, if you say sort on something, it sorts it, and then it restores it. R does not do that. If you say sort x, it's just going to print out the sorted thing and say, I hope you like what you saw, and then keep on going. You have to reassign things if you want to resave them. You have to say x equals sort x, for example. So you have to reassign x to the sorted x, right? Or, unique or something like that. So for example, in a data set, you don't just say, so the command is arrange. You don't just say arrange data set by these variables. You say data set equals arrange data set these variables. If you just say arrange, it's going to say, hey, you didn't assign it to anything. I'm just going to print it out for your pleasure and then keep on chugging on the next command. Okay? So that's one of the biggest things for new users, right? Because in Stata, you say sort, patient ID, visit, whatever. It sorts the data set, and now the next command runs. That is not how R works. You have to reassign it. Because let's say you have a data set, and you want to say, I want to keep that fine. I want to make this data set, and I want to arrange it by some other things. And I want to keep 2 separate data sets in memory for some reason. R says, fine, you can do that. I'm okay with that. But you have to reassign it if you want to overwrite that whole thing. Okay, so this is kind of what you see when you look in the environment. It's the str command, which stands for like the structure of something. So str, it says num, x is a num, it's 1 to 4, it's 4 elements, 1, 4, 6, and 8. stry, it's 4 elements, 2, 6, 9, and 12. Again, this is what you're seeing. If you want to see that without having to look in the environment, you can just say str on an object. Whether it be a data set, a model, whatever, it tells you what it is. So again, simple stuff, assigning new variables, performing some algebra, creating a new script, loading up a new project. Again, nothing way too exciting yet, but these things convey a lot of the concepts that we're going to get to that if you don't know, it's going to be a bad time. All right, so we do a lab, and there is one of my favorite things to show new R users. So we're going to go to the website, and it's not like a fun thing. It's like a bad thing. So if you go to the lab, again, the key's there, but, check out the lab, then we'll go over the key. So you should be able to click it, and you should be able to download it. So you can either right-click and hit Save, but again, if you are on Safari and hit File, Save As, make sure you make sure it's a page source, not a web archive. Otherwise, it's going to download the HTML. Or it does something a little bit different. So either right-click and Save As. So right-click, Save File As, and just save the R script. You should be able to double-click it now and open it in your RStudio. And it's the basic R lab. So it'll take about 5 minutes, maybe go over it. I mean, it's 9 questions, but they're relatively straightforward. Oh, one thing. When we put quotes around things, like in the code, we don't mean you put quotes around them in your code. We're just saying, create a second variable called myCar that contains 5 character strings. We're just saying that the object in R should be my.car. A lot of times, what we've seen happen is, for example, someone try to do something like this, like my.car equals, right, that, which, that actually does work. Okay, that works, but when they want to combine things together, it's like my.car x, right? And it gives you that, because they're quotes, they're strings. First of all, just don't do that. I didn't even know you could do that. Don't. But this means something very different than without the quotes, right? This means this is a character. Just treat it as a character. Without the quotes, it means look up and find those objects in memory. Okay. Pleasure. By the way, number 7, you should get an error, right? So if you're getting an error, it's not wrong. It's just that's yeah. We got 2 more minutes. All right. Yeah, that's what I think they just released.
I guess I have 3 points.
Oh, sorry. What's it called? You're fine with that.
Okay.
That's okay.
I was looking at it. There's a certain option.
There's not. You reinstall it. The only thing is there's a. So it doesn't overwrite things. It where the case that installs your packages is like /3.3. And so it's if you're before that all those packages that you have aren't installed, they are installed.
They're installed in the old folder.
Yeah. So
So you have to copy it.
yeah, you can't copy because, for example, the base package, the stats package, and all that stuff, the core bar
Has been changed.
has been changed. You don't overwrite that.
Oh, okay.
Yeah. So usually, 1 or 2 recommendations are there's a way to selectively copy things that aren't in the directory. And the other option is just to say like, how you want this package to install.
Okay.
All right, so let's go over some of these. So you say create a new variable called my.num that contains 6 numbers. So one thing you should note in this example, you can put periods in variable names. So more or less, there are some restrictions to that. You can't have certain special characters in a variable name. You can't have $signs. You can't have spaces. You can't start a variable with a number. You can start it with certain special characters like underscores. You can have underscores in a variable name. You can have periods. Yeah, so that's kind of the gist. Uppercase, lowercase letters, all the other alphanumerics. All right, so my.num, we chose 5, 4, 7, 8, 12, 14. Multiplying my.num by 4. So again, it does element-wise multiplication. So again, multiplies all my elements by 4. Create a second variable called my.car that contains 5 character strings. We just said Andrew and John in some order. So we put strings. So again, it prints out a little bit differently. So they have quotes. If we had put them in single quotes, it would still print here with double quotes, but it would still contain a character vector all the same. So let's combine them together. So both. We're combining my.num, which is a numeric vector, my.car, which is a character vector. And before I do any of the other commands, I type both. What do you see? Everything's in quotes, everything's a string. So what's the length of it? So it's 11. Remember, my.car had 5, or my.num had 6. We have 11. Everything's still contained in the same thing, but the class is now bumped up to a character. So this is what's at least referred to in R as coercion. Right? I mean, that's what it's called. It coerces it into a character. So we're going to talk about, so again, I briefly touched on 2 other data types. Factors, which are categorical variables. And we're going to be talking about logicals, just trues and falses. So kind of the way it goes is character is the most flexible of all of them, right? So it says, I don't know how to make a word into a number, but I know how to make a number into a word. You just put quotes around it, and then it's a word now. So that's what it does. It says, I see this character vector, I see this numeric vector and a character vector together. Remember, vectors can only have one type, one data type in there. And so it says, all right, well, this is characters, so these numbers have to be bumped up to characters. So again, now if we try both divide by 3, it says, what are you talking about? I don't know what you're doing. You're trying to divide words by the number 3. It says, I don't know what you're doing, non-numeric argument. Even though before we could say my.num divide by 3, that works simply fine. But when you combine them together, it coerces them into kind of the lowest common denominator class. And in this case, it knows how to make numbers into characters, but it doesn't know the other way around, so they go into characters. Similarly, if we do something later, true in all caps is a logical in R. We'll talk about these in a lot more detail later. But true, all caps, is a special word in R. It's a special variable of sorts. It means true. Like, it's a logical. So, for example, you cannot assign a variable true, right? All caps. And I don't mean a column in a data frame. You can have a column in a data frame that's all caps true. I still wouldn't recommend it. But you can't say like true equals 4. It says no. Can't do that. Otherwise, everything would break, more or less. There is some code online. There are some people that use T and F. So T and F are shorthand for true and false. Do not use them because you can assign T to different things. So one of the lovely things when we ever grade new students' homeworks in some of these classes, you set an environment variable of T to be false and then run their commands and see what happens. So if things break, that means they use T instead of true. Yeah. So also, another fun thing is to reassign T to be the quit command, and then anytime they write T, it quits the entire script out, and it keeps erroring over and over again. Fun things to do. Anyway, So let's create a vector with elements 1, 2, 3, 4, 5, 6 in it and call it x. Create another vector y. So how many elements does x have? 6. How many does y have? 5. Does this command run? Yes, with a warning. This is one of the, so from people who've ever used MATLAB, this is downright heresy. This is unacceptable, impossible to do. So what happens here? R tries to be flexible in a very dangerous way. 6 elements, 5 elements. So it says, let's add them together. So it says, okay, I'm going to try my best. So it's going to say 1 and 10, 2 and 20, 3 and 30, 4 and 40, 5 and 50. It says, well, I ran out of stuff. So what it does is it's called a wraparound effect. It says, all right, well, take this whole thing, put it again. So that's why it takes 6 and 10 and makes 16. That is generally not a good thing. But also, let's note the warning message. Longer object length is not a multiple of shorter object length. It does not say they are not the same length. It says they're not multiples of each other. So x is 6 elements. Totally fine. No warning. Length 6, length 2. I don't know why this exists. The only things I can think of are like there's probably they're like, this is the why it happened, or this is why it was like this. But I can think of some data sets where people like to color code Excel files where it's like case control, case control, case control, case control, case control over and over again. Like where that's how they structure their data, but they never have a variable that says case or control. That's the one case where I'm like, okay, and then you can make a column and you say column 5 is like 0, 1, and it repeats 0, 1 and over again. But anyway, this is one of the, they call them gotchas in kind of a new language. So this is something that users who've been around for a long time know about, but you might run into if you aren't necessarily careful. If you're adding 2 columns of a data set, this isn't a problem. They're guaranteed to be of the same length. But if you're working with vectors and things kind of outside a rectangular structure, this stuff can happen. There may be some pathological case where you want this to happen. Generally, it's not. So that you should just be aware of. And that the first one, this one is way scarier than that one. Because there's no warning here at all. Okay? Just be aware that that exists. All right, so append the value of 60 to the vector y. So again, we don't have to say y equals 10, 20, 30, 40, 50, 60. We could say, take y, collect 60 on top of it. So now, y is of length 6, x is of length 6. We get the element-wise operation is done again, but now it's not 16, it's 66. Okay? So 2 big things done in the lab. Coercion. And so where, numerics turn into characters. We will talk about coercion a little bit later too, because sometimes when you say, I have a character vector, and for some reason R read it in as a character vector, but it's all numbers. I think it's all numbers. And you say, make it into a numeric. What will happen is if things are in there that R says, I don't know how to turn this into a number, it's going to turn that into missing. And it'll give you a warning that says, NAs were introduced by coercion. That's the warning it'll give you. So for example, both, we'll talk about this command later, as.numeric, say, I want it to be numeric. I know it's all numbers. NAs introduced by coercion. So it said, I want to make this numbers. And it says, oh, I don't know how to make 5 number, 4 number, so on. It says, oh, I got the Andrew, I don't know what to do with that. That's a problem. It'll be one of the example data sets we use. We'll read in a file that has salaries. Salaries, they'll all have dollar signs in there. And R, by default, is not going to say, oh, I know that's a salary. I'm going to strip that away. There's a dollar sign in the text, so it treats them as characters. And if you say as.numeric, make it into a number, it's going to make them all missing. Because it says, I don't know how to work with dollar signs. Okay, so is everything clear in this lab? All right. So today is a lot of talking, and then lab. The other labs will be a lot more interspersed within the lectures. There's a lot of build-up today. So data input and output. So we're talking about how to get some data in, usually text, CSVs, so TXTs, whether tab delimited, CSVs, whether comma delimited, or Excel files. We will talk about a little bit about getting SAS and SATA data sets into R, and some fun with that. And if we have some time, I'll show you an example of getting a data set from SATA into R and some fun stuff with Shiny. All right, so again, new user problems usually. Working directory problems. Though you guys are usually, if you understand working directories and usually you try to read a file in and it says, I can't find that file, 9 times out of 10, it's just the path is specified incorrectly, or you have some sort of typo, or some sort of case sensitivity problem, right? You thought you typed the name right, you didn't, like an X was a capital versus a lowercase or something like that, and the file name was just a different file name. RStudio can help, and so do RStudio projects. I will show you that in a minute. So we're going to discuss that. That is in this lecture. I don't know why it's in there. Again, no, we're just highlighting this one. The working directory problems are usually the biggest problems for data input or output. Okay, so again, our lecture files on your computer relative to your working directory. So there are some functions that allows you to see. Get WD stands for Get Working Directory. If you look on your RStudio console at the top, it should tell you what working directory you're in. Set WD is an okay command. I would use it with caution. I generally don't set my working directory because I work in the infrastructure of RStudio projects. So I say every time I load this project up, I'm in this directory. I work relative to that. If you would like to set your directory, set WD is the way you can do it, and I will show you how to do that on the drop-down menu in a minute. But again, some people have different philosophies on this. Some people always assume you are in the directory. You will be in the directory that the script is in. So whatever script you're running, they assume that whoever runs this script, they will run this script, and when they open up R, they'll be in that directory. Again, if you open R file with a new RStudio session, this does this for you. If you do set a working directory, always set it at the beginning of your script. I will not recommend switching working directories multiple times within a script. I don't think that's very robust, unless they're all relative paths, and we'll talk about what that means in a minute. But I generally don't do that. So, really quickly, talk about setting the work directory. Let's go into R. So, session, set working directory. You can say to project directory, to source file destination, to file pane destination, or you can choose the directory. So it can either say if you're in a project, wherever the project's in, or if you're working in a file like I am right here, this index.rmd, if I say set to source file location, for example, it'll set it to the directory of this file right here. But usually, if you want to just do this interactively, you can choose the directory, go through and say, I want to start here, and then start your analysis. And again, up here on your console, it should tell you where it is, where you're at. So just session, set working directory is one we can do that with a drop-down, but set WD is the command. So pretty much, if you're going to use anything with directories, use forward slashes. Okay, and forward slashes. So for years, I didn't know why they call these. So I believe it comes from fencing. So slash forward and slash back. I don't know, but that's the way. At least I remember that now. When you slash forward, so it goes like that way. So a forward slash, use those. So those are robust to Windows or Linux and Mac. Backslashes, they're a different story because they are used for other purposes. They are called what's called escape characters. We're not going to get into them, but if you're specifying paths, use forward slashes. So Mac and Linux, they assume you're using /, so that's fine. And again, typical directory structure syntax, so if you do double dot, that means up a directory. / means this directory. Tilde is your home directory. And on a Mac, it is like home username, I believe. And on Windows, I think it's My Documents or something like that. So, for example, when I go back to my intro to R, it says like tilde, Dropbox. Sorry, it's like /users. So if I say get WD, users, John Michelli, Dropbox teaching, intro to R. So users, John Michelli, my username, is the tilde. Is tilde shorthand for that. So my home directory is users, John Michelli. Right, so if I wanted to set there, I could just say set WD. And the reason we say RStudio can help, if you say quote, tilde, / and then you hit tab, it'll scroll through directories. I'm like, I want to go to Dropbox, and hit enter, or sorry, I hit tab again. Dropbox, I know teaching, hit tab, intro, hit tab, and then I'm there. So I don't have to necessarily remember, or I don't have to, mistype some sort of directory name, or, forget which is a lowercase or an uppercase. So when you open up a quote, you can usually do tab completion. So if you quote, I'm going to do tilde / and hit tab, and then I'll be able to scroll through these. Okay. And so if I say this, ... / I'm saying go up 2 directories. Right? So if I go up 2 directories and I say get working directory, I've gone from intro to R up to teaching, and then went back up 1 more to Dropbox. Right. Just a relatively standard syntax for directory structures. Okay. So sometimes if you don't want to look in the file panes, there's other commands that are helpful. Dir is one of them. That'll just show in your working directory what's in there. So just dir, if you say dir without anything in there, it'll just show the working directory. Dir, in this case we just say dot, which is equivalent to saying show everything in this directory. If I say dir ... it's saying show me everything in the directory above this that I'm in, and we can see the files on my computer, because sometimes I'll say read in a file and says that file's not there, and I say dir, and I was like, oh, okay, I didn't save it there, I thought I did, and I'll figure out where it is. So okay, a little aside on relative or absolute paths. So an absolute or full path points to the same location in a file system regardless of the current working directory. More or less, this is the way I would call like a hard-coded path, right? Something that says this works on this computer, it's probably not going to work on your computer, right? Like if I wrote read in the file at users, John Michelli, Dropbox, teaching, intro to R, whatever, right? I doubt that folder, that whole file structure is on your computer, right? So that's an absolute path. So that's fine, and that works on your computer, but it's not really great for sharing code or, giving it to someone else. That's why we always recommend relative paths. So it starts from some working directory, and you don't have to specify what that directory is, and it specifies everything, reading data, all that kind of stuff relative to that path. That's the other reason why we introduced RStudio projects. Okay, so you can do this where you can say session. We already showed set working directory. Let's say we said source file location. You could have changed it like this. I'm not going to change the directory. It's not going to be a big deal because we're just going to show you how to read in some data. And if you have that project open, you should be in the project that you need to be in. So again, we also went through this. You should, I believe, associate all .r files with RStudio rather than the R application, so that when you do double-click them, it opens up RStudio and not something else. So help. Number one thing you need to learn how to do is find help when you need it. So there's 2 simple ways to look up the help file for a function. The shorthand way is the question mark. You say question mark function name. So question mark dir, I'm going to run that. Question mark dir. What it does is it brings a little help file up here. We'll break down structure of this. So, okay, so it says something in curly braces, in this case, base. That means this function is in the base package. This is the title, list files in a directory folder. This is the description, a little bit more detailed. The usage says this is the function and all the arguments of that function. Okay, and those are all the defaults for that function. And then arguments tell you each one of what those arguments are, what you're supposed to pass in, all that kind of stuff. Value says this is what you get out from that function. So arguments are what you put in, value is what you get out, some other notes, who wrote it, and then examples of using that function. So that is a help file. So if you're like, I don't know how to use this function, first thing you should do is question mark that function. Question mark that function, bring up the help file. Another way you can do it, if you don't like the question mark, you can say help, excuse me, help, and then the function name again, and it'll bring you the help file as well, rather than the question mark. So everything we'll be using, for the most part, is going to be real data. A lot of it's from open data or data.gov. So I think we're using some youth tobacco survey, some of the circulator lines, some of the salary surveys from 2015, stuff like that. All right. So reading in data, again, this is the first step of any real analysis, right? So you need to get the data in there so you can start working with it. Most of the time, again, it's going to be in ASCII format, some sort of tab delimited, comma separated, or usually some Excel file. Again, you might get some data sets in SAS or Stata or something like that. But for the majority, all those can be exported into, Outsheet or I forget what the equivalent in SAS is. But all publicly available data, mostly you get something like this. I did try some of the DHS data with their DAT files. I wouldn't recommend that. We're going to read in their SAS data files and then use them labeled there. You can read in almost any file format for the most part. Shape files for maps. You can read in SAS, Data, SPSS. You can read in Excel, XLSX. I don't know what Minitab makes. You can probably read that in. Yeah. So if you have it, you can either read it or convert it, then read it.
Are there with Stata, you can't, if you have an older version, you can't open files from a newer version. Does R have the same issue across versions? Or?
For R, no.
Okay.
Reading in Stata version from multiple versions, yes. So the package I'll show you, Haven, I don't know which versions it can read. There are some additional packages. I believe there's it's called Read Stata Data 13 or something is like the package name, specifically because they've changed the formats from 11, and I think they changed it in 13, and I think they may have even changed it again in 14. Yeah. But R, generally what they save it in is ASCII format that's compressed. So zipped up text, more or less, in some formats. So I've never heard of anyone who hasn't been able to open in what they're called as RDAs or R data files from previous years, because they're pretty simple, right? And they're not proprietary, right? They're open, and they touch them. I believe they touch that format very lightly. They don't really change that too much because it would break a lot of stuff. And if they do, they usually write workarounds to say, like, check this, if this, then read it the old way, for example. All right, so I'm going to use some of the data from the Youth Tobacco Survey. You can read all about it. They were pretty much measuring kids for tobacco use, smoking cessation, like counting the number of packs a day they were smoking, with some looking at how kind of media was impacting that. So, two things. One, all the data will be filtered through my website, and let's look at the website because there should be a zip file if you want to download all the data that we use for this class. If we look at that, there should be data. I just looked. So, okay, if you go to the data header, all the data that are not specifically to be downloaded from the web are in this file. So anything that says like John Michele, intro to R, data, whatever, you can just download this zip file and it should have everything in there. The majority of the functions we're going to use, though, will read data straight off from a URL. So that's what we're going to use for some of these functions. So, but if you want to download all of it, you can use this. Also, whenever we say a data set, we will provide the link for that data set or that CSV. The majority of it will be CSV. Okay. So, again, with Safari, make sure you save things as a page source. We can set the working directory, but that's not really relevant right now. All right. So what I would recommend, copy this link in the data input. Copy the link to the data set. So I think about 2 years ago, this didn't really work so well, but it's since been a lot better in our studio. You can easily import data sets using a drop-down menu. And the nice thing about it, it will give you the code relevant to doing that. So I'm going to go into my R project. Let me zoom out a little bit. We're going to go to File, Import Dataset, and then from CSV. All right. I'm going to paste this URL in there, and I'm going to click Update. So, this is what it's going to do. Here are a couple options. It's going to give you a little preview of what you're going to see if you read it in with these options set. And here's the code down there to read it in. Okay? If we change these options, this will change. It'll change the respective code. Normally, you don't. If things look right, you don't need to change anything. But a lot of times, the name, excuse me, the name defaults to the name of the file, which is usually not what you want as a variable name, right? So this would be called Youth Tobacco Survey _YTS _ data, right? With caps and all that kind of stuff there. I would probably name this like YTS or something like that, right? So that's the thing I'll be operating on in R. And again, I think it's a personal preference, but the RStudio people think it's a better way to write. So they use the assignment operator. But when I click import, it's going to run these 3 commands. So it's going to read this library, read R in. It's going to use the read _CSV function to read in this function, this file, and then we're going to look at it. We're going to view it. So I'm going to click import. It'll take a second. So 2 things happen. One, it says it parsed it with this specification. We'll talk about that in a second. It read it in, it loaded this library in, read it with this function, and used view to actually view. So although you could have used view like we did before on that X, that X variable, wasn't really nice, wasn't really pretty, wasn't really intuitive. This is a much better view. This is much more intuitive, much more like what Stata gives you. So you see down here, for example, it says showing 1, let's see. Showing 1 to 13 of 9,794 entries. The first column is year. You can do some things where you can do some searching in here. You can click filter and start doing things in here like, let's say I just want cessation. Things that have the word cessation in here. So you can do some kind of interactive exploring in here. I don't believe you can edit this, nor do I think you should be able to. I am a Stata user that uses EDI just because that key combo makes more sense to me than BRO for editing versus browsing. I never edit anything by hand, but that functionality is just scary to have, right? So, yeah, so like Excel scares me, right? That idea. So you can do filtering, some of that kind of stuff, some exploration. But also, if I take this away, I can also pop this out. Sorry, that little button. For some reason, though, when you do the preview in the importing, let me go back to show you what I mean really quickly. when you do the preview, it's nice because it tells you like what those are, but when you actually view it, it doesn't show you that. But when you type in YTS, the object we just loaded in, what it'll show you is those variables. It'll show you, I think, the top 10, and it'll show kind of as many variables that fit the screen in some reasonable way, right? So it shows you these. These are integers, right? That's what int means. CHR for characters, and it goes down the line, for example. And so you can see these are the other variables that are not displayed, but these are the variables and their respective classes. So, yes?
I don't want to hold everyone up,
No.
but I am not able to import by CSV because I need to download a package and it has failed.
Yes. Okay, so... Okay. So close it out and try to do install.packages. So yeah. So I showed you in that script on how to kind of install all the packages necessary for this class, but if you do need to install packages, Tools, Install Packages. If you go to Tools, Install Packages, this should come up. Right? And this is a way where you can install the relevant packages that you want to download or something like that. It said, oh, I want to, I heard about this package or I saw this package online. I want to install it on my machine. So, for example, in this case, read R. Right, I could have written. Just click here. And then when I click install, it'll install that. So if it failed, yeah, I'll have to come over and check that out. But, again, let me reiterate, even though we installed all those packages before, in order to use the functions from readr, we had to use the library command to load them in. To say, in this session only, I want those functions to be accessible. Okay? So read_CSV is a function inside the readr package. If we didn't load that package in, and we just tried that, it would say, I don't know what that function is. It's going to fail. During the lab, I'll swing by and hopefully get that up. Okay, so let's see. We've read it in, we've viewed it, and it's given us this thing, I'll call it. So what this is technically described as is a tibble. That's the way that's the name they gave to this format. So traditionally in R, data sets are stored in these things called data frames. It's a frame of data, right? They're great. They work really well for models and all that kind of stuff. But there are some quirks that weren't desirable, let's say. For example, when you made one, it automatically thought when you have a column of characters, convert that to a categorical variable. That's not always what you want it to do, right? So let's say, for example, you have a column that's like free text. You don't want that to convert that into you don't want a category for every single unique free text. That doesn't make any sense. Also, if you typed in a data frame like I did here with YTS, it'll just keep printing and printing and printing as long as it feels like, right? Until it hits some maximum like 10,000 rows or something like that. Generally, that's not what you want. Generally, that's not how you view data. So it does some interesting things where it says, okay, if you print this out, I'm not going to print all the columns. Okay? I'm only going to print as many that kind of fill your screen up. I don't think you want me to scroll and scroll and scroll and scroll and scroll and scroll. So that's a different thing. Yeah, also if you try to grab columns that don't exist, so let's say you made a typo, it'll give you an error, whereas data frames don't. We'll get into those a little bit later, but ideally, this is the way your data will come in as a CSV. Right? It'll be a tabular. You use view to view it, and this is the kind of landscape you see kind of with your data. And we'll talk about how to do tables of this kind of stuff and see, the formats of all the columns and stuff like that. All right, but the nice thing about it, again, you should copy and paste the code that was given in that little box to your script. And now you have a reproducible way to read that data in the next time you boot up R. Okay. So again, this was I just did this where I showed you, read underscore CSV, and I assigned it to something called mydat, and I just said head. So again, head is the way I usually explore my data sets rather than maybe view. View is a much more intuitive, interactive way, but I'm usually just at the command line, maybe not always in RStudio. So this gives me kind of a snapshot of what's going on. There are a lot of variables in this, so it might not be that intuitive. So we'll talk about in data subsetting, like how to view only a certain set of columns or only a certain set of rows. So what's going on behind the scenes? So there is a read underscore CSV function, which kind of piggybacks on this function called read underscore delim. So it reads delimited files, whether that delimiter being tabs or spaces or semicolons or multiple things like that. And it's got a whole bunch of options, which if the data is formatted in a relatively standardized way, and I mean standardized is the way I'd say like 75% of CSVs are formatted, this stuff you don't really have to change. But there are some times where you want to change these arguments around. So let's say you have a CSV, but somebody put a little bit of a header in there saying like this file was generated on this day, but that's not actually part of the data. So that's what the skip argument, for example, is about. So if you look through the help file, you'll see what all these arguments are for, and sometimes you do have to change the default so that, for example, you skip that first line. You'd say like skip 1, and then it knows that's not part of the data set. I don't want that. This data was built on this date, right? That's not what's relevant. Also, you see NA, right? So NA is the missing unit in R. So it says these are the two things that I'm going to say. If I see this, I'm going to say it's missing. So if I see the two letters NA, just that in a cell, I'm going to convert that to a missing value. If I see an empty string, I'm going to convert that to a missing value. Sometimes you want that, sometimes you don't, right? That being said, sometimes, for example, in Excel, something that looks missing to you actually has just a space there. That space will not be treated as an A. But if it's a cell where it's truly empty, there is no data in there, it'll be converted to an NA. Okay? NAs we'll talk about, they're not the same in Stata. They are not treated as infinity. They aren't treated as negative infinity like they are in SAS. They are their own thing altogether. So again, the file name is the path to your file, but it's in quotes, right? We can't just put the entire URL in there. We have to put in quotes, tell R that it's a string. The function will look in your working directory if no absolute file path is given. So if you give it relative, again, in this specific function, you can give it a URL, and it knows how to handle that. But not all functions that read in data can handle URLs. So we'll talk about Excel in a minute, and for some reason, I believe on Linux or Mac systems, if you read in the Excel files, it was fine, but the downloading for some Windows machines wasn't working right. So we said, download the Excel, and then we'll read it in. Okay, so the read.delim is kind of the main workhorse that's actually going on, but the read CSV function is the one we're using. And again, if you print out a function, if you just print it out and just type it, it'll try to print the source code. And one of the things at the bottom will say environment namespace readr. Again, not super intuitive, but what that means is this is the package that it's in, right? So when you print something out, it says this is the package, okay? So again, the quotes, the arguments are the same, with one last one that I want to know. Col underscore names. So sometimes you do have CSVs that have no headers, right? So if you set that to true, it assumes that the first column is the header names. It's not always the best. So if you set that to false, it'll assume the first row is just data like the rest of it. Okay? So this is just an example of and I'm delving into these details, the arguments of this, because these are some of the most important functions getting your data in. So these are the things also I change probably the majority of the time, if any, of the arguments. So col names to say, no, there is no header. NA to say, I might put in another argument here. I'll do a quote, quote, comma, NA, comma, quote, space quote to say just a single space, treat that missing as well. I may do that. I may skip a row. Yeah, those are kind of the majority of the arguments I would change. Or alternatively, again, you can do this multiple ways. I might just read the data in standardly, and then for certain columns that I care about, I might just say, if you just see an empty space, convert it to NA using code later, rather than doing it when I import it. So either import the spaces as spaces, and then convert them to missing, or when I import it, convert it to missings on the fly. Okay? So again, it doesn't have to be a URL. So in this case, I'm saying let's go a level up. Let's go into the data folder, and let's read the youth tobacco survey data in here. And again, we get the same exact thing we get out. If you write spec parentheses YTS, it'll tell you how it read it in, what it chose to be the classes or the data types for each of the columns. So it says year, I think it's an integer. I said that was an integer. Location, character, so on and so forth. This one is a double, which is a numeric, for example. So you can use this later if for example, in read CSV, col types is an argument, right? That if you don't put anything in there, it's totally fine. It just makes educated guesses as to what the columns are, right? And it won't do anything. It won't do anything, I would say, very unexpected. It won't, for example, like take words and make them missings because it says, I think this column is supposed to be numbers. It won't do anything like that. But if you say, I think the column types, I want it to be this exact specification. I don't want you to import year, for example, as an integer. I want you to import it as a character. You can take this specification, tweak it to whatever you want it to be, and pass that in there. So again, for your first pass, it doesn't matter, but for those who really hammer down on quality assurance and quality control, this is some of the tools that you use or you need to say, for data consistency, especially with some of these larger studies, that like if the data is not this way, we have to stop, go check our pipeline and our process because something's gone wrong there. Okay, but for the most part, I don't necessarily specify all that stuff. It usually comes out to be what it needs to be, or I do some checking on my own to say, like, is this a character or vector, or is this a character or numeric? If not, turn it into a numeric, because I usually need to do some exploring of the data to see why things have changed anyway. Again, so it returns this tibble. Read.thelim is useful, but it's kind of like a lower level function. So there's a read underscore TSV. So if you have a tab separated value rather than a comma separated value, that's what you'd use, right? So sometimes some formats for some people can be very, very complicated. They can mix and match like colons and commas to be separators and stuff. Those are just kind of on a case-by-case basis. You have to kind of work through. There's, not some catch-all that's like this magical tool that'll parse anything. Right? But CSVs are the majority of the time, I would say. Yep, we're not going to go over that. Okay, so there are versions of these functions in base R. So they are read.delim, read.csv. So although I've used them for years, I would say not necessarily to use them as a new user. So the big difference is the periods. These are the base R versions. They do not have the same behavior necessarily. The read underscore versions from the read R package are much faster. especially for very large data sets. So if you look online and people are recommending this, you can more or less use the read underscore versions of these as a replacement. These are just older. These are just the way a lot of people use them. But again, they have some quirks that really was the reason they made the read our package. So more or less, I'm going to say we're not going to use the read.csv, read underscore CSVs. Also, it gives you a slightly different format out. So the read underscore CSVs give you this thing called a tibble, which has this interesting format, and it shows you like the column types and all that kind of stuff. These give you a data frame, which I said is very powerful and has been used for a long time, but it doesn't have some of these additional features. And moreover, when we start talking about loading in data sets, for example, from Stata, it'll be in these tibble formats. And these tibble formats have these nice properties that when you read it in from Stata, you can get a variable that's like 1, 2, 3, 4, 5, 6, and it'll have the labels associated with it, and then you can convert those to something a little bit different. But a data frame doesn't have the ability to have those special properties with it, so that's why we're not going to touch on those. So just to show you the difference, so we said read.csv, and this is when we show the head, right, the head of the data. So we see its format. It looks very similar, but it doesn't say anything about the data type. It also keeps printing. It will print all the columns. So not always what you want. You can still use view on this, and it'll, you can do filtering and all that kind of stuff. And the most important thing here, as.is equals true, specifies that when you read in a character, for example, the topic type, you don't want to convert that into a categorical variable, right? Because there are reasons for that. You can't do can't do manipulations like with characters in the same way. When you convert these things to what we're going to talk about a little bit later called factors, categorical variables, you can't do replacement in the same way. Because with a categorical variable, you say these are the levels, right? These are the levels of the categorical variable. And if you try to put a new value in that column that's not of those levels, it usually will give you a warning, but make that missing. So it says, hey, I don't like that, right? But it says that's not a level that you're allowed to do. You can do that. You can make new levels, and we'll show you how to do that. But you have to say, okay, we'll relax it a bit, make it a character, we'll change things around, and then we'll make it a factor. So what I'm trying to say is you usually convert characters to categorical variables later down the line after you've done the cleaning, for example. Because let's say you have a sex variable and it's male spelled like 10 different ways, or there's spaces all over the place. You usually do the data cleaning on strings, and then once they're nicely organized, then you convert them into factors. If you're working with already really well organized data, it's not usually as big of a concern. Okay. So some other quick functions. So again, length for vectors, you usually use dim or nrow or ncol for data frames or matrices. So nrow gives you the number of rows. Ncol gives you the number of columns. Dim gives you two numbers back, the number of rows, then the number of columns. So 9,794 and 31 columns, 9,794 rows, 31 columns, and then column names, sorry I got cut off here, will return the names of the columns. What are, in this case, the variables of this data set, right? And similarly, there is a way to specify row names. We're not going to use that as much. We're going to use column names because, usually don't label the rows in the same way.
Does the names function, is that the same as column names?
For a data frame, yes. So a vector can be named. So like we said before, John, Andrew, all that kind of stuff, it could have been, we can actually assign names to that. The names functions will access those, but the column names function will not access those. So it's a little bit different. So usually you're just more explicit as to which one you're trying to grab. And for the most part, you really are changing stuff about the column names. But if too short here. Yeah. So for a data frame or a tibble, I'm going to keep using the word data frame over and over again. Again, that just means like a rectangular data set. I'm going to use that kind of interchangeably between tibble. I think tibble's a weird thing to say, so it just doesn't sound right to say. So I say data frame a lot, but more or less they're either one can be used for analysis for anything. So you can use column names. Names is a little bit more generic, but for a data frame or a tibble, when you say names, it's saying grab the column names. So now we'll get to subsetting in very, very extensive detail tomorrow. But this code, for example, says names that will give you all the column names. Great. This says names that, bracket 1 says the first one, I'm going to assign that to be here. So this is one of the ways that we're going to show you how to rename columns of a data set. So it says names that bracket 1 equals year. So this is a little bit confusing because there's two things going on. This function returns all the column names. Great. This command is not returning anything. It's actually reassigning something in the data set. Reassigning an attribute. Reassigning the column names. And we're only reassigning one here. Right? But we can do this in a more wholesale value to say, for example, names that equals, there's a function called toLower, T-O-L-O-W-E-R, that lowercase is everything in a string. You say, I don't like uppercase, I don't like mixed case, I don't like any of that stuff. I'm just going to say everything's lowercase in my column names. Right? That's one way you can do it. ToUpper is the alternative. I forget what it is in stated. Is it ToLower? I don't know. There's something I used to use. I don't know. Yeah.
Just on that,
Mhm.
so this would just move the year column.
So it doesn't move it.
It doesn't move it. It just treat it as the first column.
It was the first column. So year was the first column.
Okay, so what does the first command do then?
The first command says instead of all caps here, it says lowercase. So it changes the case of it.
Does that also change it?
No.
Order.
No. Very much not so. So if I said names that 2 equals lowercase year, this will be the all caps year. This will be lower caps year, even though that column is the location abbreviation.
Okay.
So it's like rename.
It's
rename, yeah.
not exactly.
Okay.
There's a function that we're going to use rename.
Okay.
Right? That's going to be more or less identical to the rename function in Stata. This is more flexible, and every time, pretty much the take-home message, every time I say flexible, that usually means flexible and dangerous. Flexible, if you don't know, but if you don't know what you're doing, dangerous. So what I'm saying is, this is a little bit of a dangerous syntax for you, because you're saying, let's say that data changed for some reason. Somebody's like, I re-uploaded a new one, and you went to download it again. But they put the first column to be the location abbreviation. They switched these two columns. And you had this command, it's still going to change the first column, whatever that column would be, to be, right? But it's not doing any string matching or anything like that. We will show how to do that, but again, this is an example of change. You know, like, first column's always year. You can change it to lowercase here. So showing two things, the column names or the names command accesses the column names and can also be used to reassign them. Okay. So the readr is like a bad name for this package. I mean, it's a good package, but because it can read and write. So pretty much every command, read underscore TSV, read underscore CSV, read underscore delim, there is a corresponding write underscore TSV, write underscore CSV, write underscore delim. That will do, it'll take in this data set, the path where you want to output the file, the delimiter, what do you want to, for missing values in there, how do you want that to be coded? You can technically append a CSV. So what that'll do is it'll read the CSV that's already there, append the data you're giving to the bottom. I almost never do that. I don't know. Yeah, I don't know many people that by default in Stata don't always have like replace on, like save to comma replace. I think I don't know anybody that's like that saved me, right? That's more kind of a default that I think most people use on the regular. Okay, so again, we already talked about this. Path is the file name. So usually just use write_CSV or write out of CSV. Again, like I said, there are versions of this in R. Write.csv, write.table rather than underscores. We're not going to use those. They're not as robust. They're not as fast. But again, in a lot of code online, you'll see them used. So again, in this case, we change the first column to the year, not all caps, not lowercase. The first letter will be capitalized, and then we write CSV. We pass in that data set. We say path equals this youth tobacco with new names. So two things you should see here. One, we passed in these arguments separated by commas like we've been doing, but here you can. When you specify an argument, you can specify it by the name. So it's not always, you don't always have to remember the order of the arguments of a function, right? So like I said before, it goes write the lim, or write_CSV, for example, the data set, path, the lim, what do you call missing? Append, right? You don't have to remember the order of that as long as you remember the name of the argument. And that might seem harder, but again, tab completion is very nice because if I say I want to write this out, so I say, let me clear this out, write_CSV, and I open the parentheses, and then I hit tab. It says these are the arguments, and then nice next to it, it says this is what you want to do. This is the definition of that argument, and you'll note over time. These things have different colors because they have different meanings, right? When you do tab completion. So before, if I say x equals yts, and then I say path equals, and I do quotes, right? And I hit tab, right? We don't see these little red. I don't even know what those purple things are. For example, if I do that, I don't know what that's supposed to be. This means argument. Purple thing means argument. I don't know. But if I do this where it's open quotes, we see that it's this is a folder, this is a file. So let's say I want to do this in this directory, intro to R, teaching, intro to R, and then let's say I just want to put my desktop, test.csv, right? So now let's say I want to append, so I can hit comma and hit tab again and see that these are the columns of that argument. So tab completion, although if you don't remember the order of the arguments, as long as you remember the name, or you're just saying like, okay, I put a comma and hit a tab, I forget the name of the argument, you can just do that and that'll walk you through the process. All right, Excel. Okay, Excel exists, everyone uses it. More or less. A lot of times you just have people save data into a CSV, but sometimes you want to read directly off in Excel. There are some add-on packages, XLSX, read Excel and open XLSX. Almost every time we're going to use read Excel. The only reason you would use this package, I believe, is if you really need to write an Excel out. And if you need to do that, you need to talk about the process and what's going on. Right, because if a CSV is not sufficient, it needs to be Excel. Something's gone a little bit weird, in my opinion. So that being said, it reads like tabular data from Excel. I don't know what happens if you have an embedded graph in Excel. I don't try to read those in. I haven't had to work with that. So if you have to work with that, I don't know. But read Excel is a really good package. But again, usually I often save it as CSV. So I'll show you that right after these slides are over. So the big package that I want you to really know, Haven. Haven is the new and improved way to read SAS, SPSS, data formats. So again, this is put out by RStudio. It's a really good package. It reads things very fast and it puts them in these, puts labels in a good way. And I'll show you a very brief example on how to do that. Read Excel. I'm going to show you an example now. That has a read_Excel function. So the read Excel package has a read Excel function. It can read Excel spreadsheets very easily. Read_R, it's the way I would say to do reading and writing for CSVs, any regular tab delimited any delimited files out there. There is a SAS7 BDAP package that can read and write SAS7 BDAP functions. I would say Haven. I wouldn't use that function package probably anymore. Foreign is the long ago precursor to Haven. I don't think it any longer works with like Stata 13 things and stuff like that. And I think they just said we're not maintaining this really anymore. Okay. So yeah.
There's no single command that can read pretty much everything.
No. I don't know of any language that has that.
Right.
Yeah.
But I thought ours
This-
is more magical.
Well, it sounds like Haven is good for everything.
Haven is good for everything, but you still have to say like, what is it?
CSV and Excel.
Well, yeah. That's generally because those functions usually have some sort of checks in it. Yeah. So there are ways to do that. So I believe there's got to be at least a few functions that do switches that say like if the extension is this or this or this, use this. The problem is that sometimes you need to change the arguments to make some things work. Right? The same defaults don't work for every file. Right? So if you want to change it, that's fine. But like read_CSV doesn't necessarily have the same arguments that read Excel does and stuff like that. So it's hard to be able to say like, oh, if it's Excel, then like, you know, I want this sheet, right? So it's just differently relevant. But yeah, there should be a read_ for anything, almost. Okay, before we get to this, let's go to our let's see. Give me 1 second. I gotta find an Excel file. Okay. I'm just gonna find one on monuments. All right. I'm just gonna show you. So okay. So import dataset. Again, it should. So these are pretty comprehensive with respect to what you're trying to bring in R most times. So if you say read Excel or from Excel, okay. File or URL, I'm going to browse to, I'm just going to go to data. There's a monuments data set here. Let me bring this out a little bit. Okay. Give me 1 second. It didn't like when I zoomed in. Okay. Here we go. Okay, so let's just say you have an Excel spreadsheet. So this is the monuments data set. So these are the monuments around Baltimore City. So again, this was doing some weird downloading crashing problems. So if you need to read an Excel file, reading it from a link, I would say if that doesn't work, just download the file and then read it off your local directory. So in this case, I'm saying just this monuments data set. This is the way it's going to look. The location, here's where some missing data is going to be, blah, 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 blah. Similar, very similar input to what we had with the read_CSV. It says, what do you want to name it? Again, I would change this to something a little bit shorter. I don't like object names that really long. Do you want me to open the data viewer? Do you need to skip any rows? Which sheet do you want? Stuff like that. Right? And then here's the code. Again, we're not using the read_R package anymore. We're using read Excel. And we're using the read_Excel function rather than the read_CSV function. And then view will pop it up. So again, now we have, again, capital V. So we can do some filtering, some fun stuff here. So now, pretty simple to read in some data from an Excel spreadsheet. And if you had multiple sheets, it will grab those. Or you can specify the sheet that you want to read in. And then let's see. I haven't done it this way. Let's try a stated data set. So I grabbed some of the DHS data from Mali.